We're going to be using our sum and difference formulas to solve a different type of problem. And this is going to be using some of the stuff that we've learned before in previous units. So our problem says, suppose sine of alpha is 4 over 5 and sine of theta is 5 over 13. So right away we know we have two different angles. One of them is alpha and one of them is theta, where alpha is between 0 and 90 degrees. So let's sketch a picture of alpha. If we want this angle to be between 0 and 90 degrees, here is 0 degrees, here is 90 degrees, that must mean that it is in quadrant 1. So my alpha is in the first quadrant, and what I know about alpha is that sine of alpha is 4 over 5 from right here. Now I know that sine is y over r, so this is telling me that for this angle, so if I were to draw this as a triangle, my y value is 4 and my r value is 5. So what I don't know here is my x. So just like what we did in a different unit, in this right triangle we have to figure out what x is. So we're going to do x squared plus y squared equals r squared. R is our hypotenuse. So we know that y is 4 and r is 5. So I'm going to plug in for y and r. Simplify. So 4 squared gives us 16, 5 squared gives us 25. And now I'm going to solve for x. So I'm going to subtract 16 from both sides. That gives me 9, and then to get rid of the squared, I'm going to take the square root, and that tells me that x is 3. Now because it's in the first quadrant, I know that my x value has to be positive because it's going to the right and not to the left. So this tells me that x equals 3. So this is sine of alpha. I can now find cosine of alpha because I found out x. Cosine, which is x over r, is 3 over 5. So today we're only going to look at sine and cosine. Tomorrow we're actually going to be looking at tangent as well. Okay, so this is my first angle, alpha. I'm going to do the same thing now for theta. So this angle is between 90 degrees and 180 degrees. So here's 90, here's 180. This tells me that theta is in quadrant 2. This is my theta. Again, they've given us one piece of information about theta. Sine of theta equals 5 over 13. Sine is y over r. So if I draw my triangle, I know that my y is 5. And my r is 13. And again, I'm going to have to figure out what my x value is. So again, with the Pythagorean theorem, we have x squared plus y squared equals r squared. We can plug in y is 5 and r is 13. So x squared plus 25 equals 13 times 13 is 169. Get x by itself, so we subtract 25 from both sides. That leaves us with x squared. And 169 minus 25 leaves us with 144. Square root both sides to undo the square, and that leaves us with x is 12. But in this one, unlike our previous one, our x is moving to the left. So on the left side of your y-axis, x is going to be a negative number. So we know that x has to be negative 12 because it's on the left side. And so now to find cosine of theta, cosine is x over r, x is negative 12, r is 13. here's my sine and cosine for theta. So be very careful with your labeling. This one's alpha and this one's theta. They're two different angles. Now we're going to use this information to find sine of alpha minus theta and then cosine of alpha minus theta. So far this stuff was all from a previous unit. Now we're going to add on what we learned from this unit. So sine of alpha minus theta, this is going to be one of the formulas that we learned yesterday. So it's sine and it's subtraction. So if I go look at my formulas, I know it's going to be number 2, because this one has a sine and a subtraction. So I'm going to rewrite this using the expanded form. So this is equal to sine of A, which is alpha, cosine of B, which is theta. So here's my A and here's my B. Minus cosine of A, which is alpha, and then sine of B, which is theta. And so we've already done most of the work for this problem because we found out what sine of theta, cosine of, or sine of alpha, cosine of theta. We know what all these are. So we're actually just going to go and look at what we found and plug it in. So let's start off with sine of theta, or alpha. Sine of alpha is right up here. We know that sine of alpha is 4 over 5, so we're going to replace this with 4 over 5. This is being multiplied by cosine of theta, so now we're going to go over to the second one. Cosine of theta is negative 12 over 13. I'm going to replace that. Minus cosine of alpha, so now we're going back to this first angle. Cosine of alpha is 3 over 5. And then sine of theta, so on the second angle, sine of theta is 5 over 13. So I'm going to plug that in as well. So the first part that we did is really most of the heavy lifting. Now we're just plugging it in. Okay, so when we multiply fractions, we're just going to multiply straight across. So we're going to do 4 times negative 12, gives us negative 48, over 5 times 13, which gives us 65. And then we're going to subtract 3 times 5, which is 15, and then 5 times 13 again, which is again 65. So I'm doing negative 48 over 65 minus 15 over 65. My denominators are already the same, so I can just subtract 48 minus 15. So because it's negative and it's becoming even more negative, I'm actually going to add these two together. Which gives us negative 63 over 65. And that is what sine of alpha minus theta is. Okay, we're going to do the same thing now for cosine of alpha minus theta, because again, that's what this question is asking for. Find the value of sine of alpha minus theta and cosine alpha minus theta. So again, we're going to use one of our 4 formulas. This is cosine and its subtraction. So we are going to be using number 4. So for number 4, we have cosine of A, which is alpha, cosine of B, which is theta, and then plus, so be careful, even though this is a minus, in this equation, this is a plus sign. Sine of alpha, and then sine of theta. So this was rule number 4. We use rule number 2 for this first one. Okay, so again, we're going to plug in our values. We know what cosine of alpha is. It's right up here, 3 over 5. Cosine of theta, so now we use a second angle, negative 12 over 13. Plus sine of alpha, which is 4 over 5. Sine of theta, which is 5 over 13. And again, we're going to multiply across So 3 times negative 12 is negative 36. 5 times 13, we already did this one, it gives us 65. We're going to add 4 times 5 is 20 over 65. So now because these are being added, we're doing negative 36 plus 20. The denominators are already the same, so we know it's going to be over 65. Negative 36 plus 20, one of them is a negative, one of them is a positive, so we're going to subtract. And this gives us 16, and we take the sign of the larger number, so this is going to be negative 16 over 65. And we can't simplify that anymore. So this is our final answer for cosine of alpha minus beta.